Are you an AI architect, data scientist, or AI developer? Or maybe you are a beginner looking to improve your AI workflows. Or perhaps you're struggling with generating complex reports quickly and accurately. If so, then this video is for you. In today's video, we are going to show you how to solve this problem using a multi-agent system that can automate report generation. But before we dive into it, here's a quick bit of information for anyone looking to land a high-paying job in AI, machine learning, or agentic AI. If you're struggling to land that dream job, we have a completely free masterclass where our experts will discuss a proven 3-step framework and a complete roadmap that has helped many of our learners like Shrija, Mark, Debashish, Steve, and many others land high-paying jobs and certifications. So check it out. The link is there in the description and in the pinned comments. We run weekly free masterclass with our experts. So now let's get back to the video. We'll guide you through the process of creating agents that can research topics, write sections of a report, and format everything, all working together in parallel to save your time and effort. And by the end of this video, you'll understand how to build an automated system that can create reports efficiently using multiple agents working together. It's a game changer for anyone looking to improve their AI projects or automate business tasks like report generation. And also, this video is part of our AI ML Truck job oriented program. So now let's get started.
So let's see. So the input can be a default report template plus the topic. Okay, that will go to the report planner. Okay, now report planner has access to all the web search tools. Okay, based on that, it will create a list of steps. Okay, and the sections you can say. So the report template with the custom sections will be generated. Let's say you have introduction, all the sections. So these sections will be populated on the fly by the report planner. Okay. And then the conclusion. The intermediate sections will be executed by your send function. Each of these sections will be parallelly researched and executed, okay, by using our send function. So that's a parallel execution. So sections will be written by a section writer agent, you can say. Okay, so we'll be making multiple copies of the section writer agent. Okay, in which case what all things are going to happen. So basically the web search will be used by your researcher to search for the topic content. Okay, and then this will generate some queries. These queries will be searched and all that. And once finally all the answers to those queries are there, the section writer agent will actually write and append it to the sections part. Okay. Or it will give all the output to the format sections, you can say. And again, once all these sections are there, along with the introduction and conclusion. So when all the 5 things are there, let's say introduction, conclusion, and 3 sections, then the final section writer will write the introduction and the conclusion parallelly. Okay. Introduction and conclusion will be written parallelly. So this is a parallel execution of introduction and conclusion. Here the sections are being written. Here the introduction and conclusions are being written. And then output of that is concatenated into the final report template. And that is where it is generating the final report. So bit complex, but let's see the orchestration. So this is the agent which automates the process of analyze. It's a multi-agent system. So I've been talking about multi-agent, multi-agent. This is a pure multi-agent system. Okay. You don't have a single agent, but a series of section writers, agent, formatter agents. Okay. Web search agent. So all of these are ultimately each node is an agent. That's what I've been saying all these days. Okay. So agent automates the process of analyzing the user-defined topic, performing the web search, and generating the well-structured output. So this entire step. And this workflow includes report planning. Agent analyzes the user-provided topic and default report template to create a custom plan. So this is the report planner, which will take the topic and the default report template. And the sections like introduction, key sections, and conclusion are defined based on the topic. Again, a web search tool is used to collect the information required before deciding the main sections. So what all main sections would be there, okay, that is done via the web search of the report planner agent. Okay. Now the parallel execution of the research and the writing. So this part, okay, this part basically, the green boxes. So they are also enabled with web search. So queries the generated section via web search tool, and then section writing starts. Researcher agent will gather all the relevant data, and then it will pass it on to the section writer agent, which will use that gathered data to generate a structured content for that assigned section. And then the formatting of the completed sections are happening, okay, and then followed by introduction and the conclusion, because the introduction and conclusion will be based on what is there in the main content, okay, and then the final compilation in the report format. So pretty much summary of what I explained there. I've just executed this. That needs access to your OpenAI and Tavily. Okay, so again, this is the schema for the section, okay, where the description is there for that particular section, and then brief overview of the main topics, perform the web search, and then the content. So these four fields would be present in that section schema, you can say. So section name, section description, what research has to be made, okay, to populate that section content, and then the final content for that section. Okay. So similarly, there is a sections which is going to be a list of all the subsections. Okay, so it's just a list of all the sections which we created here. Okay. Then a search query tool. This is going to be used by your Tavily. And then the queries are going to be structured again. So the list of web search queries. So all the query will come out as a list. Now it could be a list of searches, or it could be list of dictionaries also. It depends. Sometimes it is a list of the queries. Sometimes it is a list of dictionaries of queries. Okay. So that is where. And then the report state. This talks about, takes the topic and updates the topic in the state. And this is the state output which will update the final report. And then the report state, this was the input and the output, and the report state keeps a track of all of these. The main topic, what all sections are there, completed sections, which all the sections have, completed. So this will be populated asynchronously. Okay. And then finally, report sections from search. That is the string of any completed sections, which is available to write down the final section, and then the final report. This is the section state. So I have the name of that section and search queries which are relevant to that section. Again, source, that is the URL. Okay. And then the report sections from the research. Okay. And finally, the completed sections. So this is again going to be a list. The final, we duplicate this. So there will be some deduplication happening, which I'll say, tell you. Okay. And then this is returning the final sections, completed sections. Now there are some utility functions. Okay. This will run asynchronously because these section agents, okay, each of them, let's say there are 5 sections. So all the 5 section agents will parallelly run a web search tool. So that web search function, which is calling the Tavily search wrapper, okay, so that will be run asynchronously in parallel. Okay, and return back the search results. So async is, why is this async? Because it's not going to be, back to back. Non-blocking means basically unless the previous agent finishes the execution, the second uh, node does not make a new search. So that is what we call as the blocking. Okay, so these all can be executed in parallel. Fine, so I'm just using the Tavily search wrapper. This is the same as the previous search query. You see, search queries, the same as that, just I'm wrapping it as a data class. Okay. And then we have the async function, which is what I was talking about. This is the function which does the query, okay, asynchronously, because we have to make parallel searches for each of these sections. And for each search, okay, 5 search results are. So the search query is given there, and the number of results include raw, false, and raw means it will have all the HTML tags and all that. So we don't want that kind of a raw content. Okay, we just need the main content, uh, the body of that HTML page, you can say, okay, by stripping all the tags and everything. Fine. So creating a empty list for query in query search queries. So we are passing that search queries as a list. Okay. So this can handle both string and search query objects, just in case the LLM fails to generate this queries as this. So basically, we have already mentioned the LLM that you have to generate all the queries as the search query based model, Pydantic. Okay, but in case if it is not returning as a Pydantic thing, it might just it might just return as a string. So in both cases, this should work. Okay. So I'm just checking if it is a search query or a query. So based on that, the query string is pulled. Okay. If it is a search query, then you are pulling this query string from the search query. Otherwise, it's just the query if it is a string directly. Fine. So I've got the query string now. Now we are going to get the results. Heavily asynchronously means parallel execution as you mentioned. Okay. For each search query. So the search task dot append. So I'm appending into this empty list that we created. Okay. What are we appending? The results of Tavily search. Okay. So raw results asynchronous mode. Okay. We are parallelly executing for each of those search tasks. Okay. Because that is what we mentioned here for each query in the search queries. So it is not going to wait for the previous. So let's say there are 5 queries. Okay. Now this execution will happen immediately back to back. It will not wait for this research results to be available and then execute the next iteration of the for loop. So all the for loop iteration, let's say there are 5 search queries. So the 5 search queries will execute almost instantly, back to back, you can say. I'm not saying that the first iteration is finished and then it goes for the second iteration. It will happen that way, but it would not wait for the previous iteration to finish because of this async. Okay, it will just extract the query string and trigger the Tavily search at the end. Okay, so once all the for loops are done, that means all the Tavily searches are done and they are present within the search task. That's the task actually. That's not the actual search result yet. Okay, that is not the search result yet. Now we have to gather the tasks and from that we have to get the actual search documents. And that is what we are doing here. So execute all the search concurrently and await for the results. Okay, so it is just going to create 5 parallel tasks. Those tasks are executed, okay, by using this async IO gather. And now we are just going to wait until all those 5, 10 searches as needed are completed. Okay. So see, the problem is not only 5. If there are 5 search queries and each time you have already mentioned that for each query, you will be making 5 results. So 5 into 5, there are 25 searches which are going to be made. Okay. So this is going to take time, and that is where we'll have to wait. So this will pull out all the results, and then there can be some empty results also. So that's the reason I'm just taking valid results, just in case if it is not an instance or an exception. Basically, that means it's an empty result, maybe failed result or empty page. Yeah, these are because there are some pages where there are restrictions that cannot be crawled by Tavily. So it will fetch the URL, but not the content. So those are anyway ignored, and that is what we are filtering out. And then finally, return the search results. Okay. And if there is any error in this execution, we'll be able to capture that and return. Because if there is any error, then don't return anything. It's like returning the empty list. Fine. Now this is going to extract the context from Tavily search results and make sure the content is not duplicated. Okay. So what does that mean? Because it's all going to be bound by the same main theme. The theme is going to be the same. Okay. Whatever the search topic the user is providing. Okay. Because of the main theme being same, while querying for these individual sections. Okay. What may happen is some of these sections may have very similar results. Okay. The search results. And that is where the deduplication starts here. Yeah. So I think there would be no result. Yeah. Deduplication of the URL and keep only the unique sources, which are basically the website URLs. Okay, fine. So I'm just taking all the scenarios where this function can fail. Okay, so this has been written after a lot of iterations. Okay, so what is it taking? The search response as a dictionary again, and also a list. So basically, it's a list of dictionaries. Um, Maximum number of tokens. Now you can basically what we are saying is for each search results, I want to just keep the first 2000 tokens. Some web pages may be very long, okay, but if you try to keep the entire context of each web page, the number of tokens can run very large number, okay. So just to limit on that, okay, so for 5 sections, 5 into 5, 25 searches are going to be made, and 25 into 2000 in this case. So basically that would mean 50,000 tokens I am using now. Okay. So if you maximum, you can go to 5,000. Okay. So in that case, what will happen is 25 searches into 5,000 token is in that case 125,000 tokens is what you would get. And that is the or rather that is close to the context window of your GPT-4o model that we have initially planned to use. Because the context window of GPT-4o model is 128,000 tokens. So we are reaching that. So basically this is decided based on the entire planning, okay, of your problem. So you can go up to 5,000 safely, assuming that we are making that many searches, okay. And for each search result, I'm keeping 5,000 tokens. Okay. So in total, we'll be having 5,000 multiplied by 25. That is 125,000 tokens. Okay. So let's for now keep 2,000 only. Okay. And to count the number of tokens, I'm using this tick token library. So this tick token library I have imported that has been created by OpenAI. Okay. So that helps us to encode text. So now the response of the Tavily search could be directly as a list, or it could be a dictionary of list. Sorry, a list of dictionaries. So in either case, so if the instance is a dictionary, okay, then create the sources list and extend. So basically you're extracting the individual, appending it to the main list. Or if it is directly a list, then you are checking if it is a dictionary. So it could be a list of dictionaries or dictionary of a list. Okay, either way. So we have seen that sometimes it is this, sometimes it is that. Okay. So again, basically the purpose of this code is to populate all the search results into a consolidated list. And if that remains as empty, then we can say that no such results have been found. Okay. And now the deduplication starts. So this is a set. If you see, I'm just pulling out the URL and updating into that set. Okay. To make unique set of URLs. And then finally, I'm fetching all the values from that unique sources and appending all the content part. If you see, I'm fetching the title, I'm fetching the URL and the content part. Okay. Again, source is a dictionary. Okay. So from there, so source.get is a dictionary function. Okay. So content is the key, same as URL, same as title. Okay. So these are the keys present in my dictionary. So this is a dictionary that you will get. Okay. So this is enumerate. So I will be the index and source will be the value. The value itself is a dictionary with these keys, title, URL, and the content. So you are pulling these values and creating a formatted text. So the text will be initially having the title of the page, then the URL, and then the content. Okay. And then separated by this kind of a separator. Okay. In each case. And if the raw content is supposed to be included, okay, you can see by default it is false. But if you want to include the raw content, okay, then make sure that you truncate the web page. Okay, to a certain number of tokens for exceeding the LLM. So that truncation is happening. So what you are taking is, so first we encode. So this will give me the actual token list of tokens for the raw content. So this would be a text. This will be the list of tokens. That list of tokens, I'm giving it to the truncated token. So how am I generating? I'm just taking the first 2000 tokens from that list and that becomes my truncated tokens. And once you decode it, you will actually get the truncated text. So this is like a token IDs and you are taking the first 2000 token IDs and then using the first 2000 token IDs, you are decoding to get those 2000 text and which you are joining with the raw content, formatted text. You are joining with that formatted text. Okay, so let's see if that worked. So let's do a direct search and see if that worked. Run search queries. Okay, I forgot to execute this. Okay, so here the query is about the LangGraph and I want to include the raw content. Let's see what all we get. Okay, so queries LangGraph, follow-up questions, none, answer, none, images, results. Yeah, so this is the result. Okay, we have got what is LangGraph. That is the title of the web page. Okay, you can click on this and have a look. Okay, LangGraph. Oh, Sahitya has written. So he was my intern last year. Fine. So here is the content. Okay, so this is the, can you see? Is there a way to skip this? Okay, so introduction, overview, and then the table of contents. So you can see what is LangGraph. That is the title. We use essential cookies. This is all the left side. Introduction to GenAI, no code, AI app development, LLM. So these are all the contents from the left side. Can you see? No code, GenAI, code focused. And then you would also get on the right side all these links. So these all can be stripped. And here comes the actual introduction. Yeah. Then another one from LangGraph. Okay. So if you see here, there is a content which is automatically generated. Okay. So we are only using this part of the content in this first, yeah, here. Okay. No, sorry, here. We're only using this content part. So if there is no content available for that page, then we are going for raw content. Okay. But in most cases, we are getting that content also, like a summary of that page. Fine. Quite good. Yeah, this is another URL, data camp, LangGraph tutorial. You can check. Okay. So this is much neat and clean because it doesn't say no, links are still there. Response time is there. Request ID is also there. There is one more from Geek for Geeks. What is LangGraph and workflow? Fine. So once this is done, we know that it is working. We can extract the documents one by one. So this is the first document. Okay. First article basically. And then you can also format the search query results to include the first 500 tokens of that result for display. Okay. Yeah. So this way, at least it is much easier to look at and understand what is happening. Okay. Yeah. This is the caret right, left. So these were all the links on the left side. Anyway, this looks much neat and clean. So all the 5 results, the source, URL, and the raw content. Okay. And then the source, URL, and the raw content. Then the source, URL, and then the raw content. You can see. And then source, URL, and the raw content. Yeah, that's how you get. So these are the instruction prompts for the report planner. Okay. So this is the report plan query generator prompt, and we have the report plan section generator. Okay. So this will generate the queries or the questions. Okay. And this will generate the sections. So we can just read this once. So you are an expert technical report writer helping to plan a report. Report will be focused on whatever topic, and the report structure will follow these guidelines, the report organization. So that report organization we have just got it here. Okay. And your goal is to generate the number of queries. So it could be 3, it could be 5, depending on the complexity. That will help gather comprehensive information for planning and report sections. So the query should be related to the topic and help satisfy the requirements specified in the report organization. Make the query specific enough to find high quality relevant sources while covering the depth and breadth. That is very good. And then this is a section generator. You're an expert technical report writer helping to plan a report. Your goal is to generate the outline. Overall topic is there, report organization is there, search context. Okay. So you should reflect on this additional context information from web to plan the main sections. So that search context is also going to be provided while using this. And now generate the sections of the report one by one. Okay. So this uses those two prompts and then does a web search, and that information is used to generate the overall structure. Right. So let's say I'm using the same GPT-4o model. Let's not change it here. And again, this is to generate the report plan. Okay. So topic will be given by the user anyway, and we are giving the default report structure template as a string. Okay. Total number of queries that will be made by the report planner. Okay, here. Okay. The web search will be 8 and LLM with structured output. Yeah. So basically this queries we have defined. Let's go and check this queries schema. Yeah, this one. Okay, so it's a list of strings. Essentially, it's going to be list of strings, list of web search queries. Okay. Hmm. And then the system instructions is there for. So in that prompt template, we are just plugging the topic, report structure, and the total number of queries that we have defined it to be 8 here. Okay, here in these three places, we're just plugging this and this and this. No, sorry, this one. This and this and this. Okay. Okay. And now we are generating the queries. So that is within the try except block. Okay. System message we have already provided, generate search queries that will help planning. And then output of that will be the query list. I'm just fetching. Okay. That query. If it is not null. Okay. So for query in results.query. So this result will be populated with another field called as queries. So I'm just looping into those queries to uh, retrieve the queries, which I'm going to save in my query list. Okay. So this will be ultimately list of strings. So now we are going to do the web search. Okay. So first the queries are generated and then the web search starts. So there will be 8 queries, and for each of those queries, we are going to retrieve 5 results. Okay. And this will happen in parallel for all the 8 queries. Okay. So run search queries. Run search queries. Yeah, this is running in parallel. So all the 8 queries will be researched in parallel. Okay. So if the search docs is not null, okay, then it goes to the format search query results where you are including all the search results without the raw content. This will give me all the search context. Okay. And that we are going to use in the planner report section here. Yeah. So report plan section generator prompt. So topic is there, report organization is there, and the search context is coming from all the results of those queries. Okay. And generating plan completed. So this will generate the sections Okay, so generate the sections from the report. You must include the sections field. So basically here I'm going to use the section schema. Okay, so the LLM exactly knows how the output should be. And so I'm just, pulling out the section strings from the report sections, which is coming from the structured LLM call anyway, and then catch any exception and print. Okay. Okay. So this is also done. So instruction prompts for section builder and the query generator. Okay. So now this will help the LLM to generate a comprehensive list of questions for the topic that specifies the section which needs to be built. So basically, we are going to generate the section content by again querying. Okay. And this is a prompt to carry out that querying process. Okay. So generating the number of queries, search results, ensure that they cover this. So this is going to populate the section. Okay. So the section topic will be given what needs to be searched. So that topic will be taken by the LLM, and let's say 5 queries will be generated for each of those section topics. So let's put all of these in nodes. So generate queries again. So 5 queries we are going to generate for each of the section. So it is pulling the section from the state once again. And after the queries are done, uh, the output of the structured LLM will have the search queries, right? So this is the node function for section builder. Okay. So this was for searching, and now building the actual content for the sections. Okay. So search the web for each query, then return a list of raw sources and they formatted. So search queries are extracted from the state. Web search is carried here. And from there, we are fetching the query results. Sorry, query list. Query list is given to the run search queries function, and all the search docs are again. So this will be again a list of the documents that we got from the search results. So how many results per query? 6 results per query. So 6 into, let's say there are 5 queries generated. So that will be 30 such results. And again, all these queries will be running in parallel. Okay. So these are the queries related to the content of the section. So it may happen that some of these queries may return duplicate URLs, okay, because ultimately they are bound to the same section. So I'm doing a deduplication, okay, and then finally format the query results. So all those 30 URLs that we got, assuming that is 6 search results, and there are 5 queries that we are going to generate for each content, for each content section. So for one content section, 5 search queries, and for each query, 6 results. Okay. So 30, and out of that 30, all may not be unique. Let's say 10 are repetitive. So in that case, the unique 20 will be taken, okay, to generate the final search context. That search context will be given to our content writer. Okay. That content writer will finally generate the content for that. Yeah, section writer. So this is the section writer prompt. Okay. So title for the section, topic. So title, topic, and the guidelines for writing. Okay. So we have clearly mentioned that each section should be strictly between 150 to 200 word limit. There should be no marketing kind of a language there. Technically focused, write simple, clear language. Do not use complex words unnecessarily. Start with your most important insight in bold and use short paragraphs using 2 to 3 sentences. Okay, you can also cite some official documentations wherever it is applicable. And then the structure is there clearly. Okay, for numbered list, unordered list, uh, section headers, headings, H2, H3, title, whatever, writing approach, and then the entire context, search context. This is the source material from web searches, which will help you to write the section. So all those 20 web links unique, along with their raw content, will be posted here. And then we are also asking it to do these quality checks. Okay, the entire content which is written by the section writer must be in the markdown format, and the entire content returned is between 150 to 200 words, excluding title and the sources. Okay, and careful use of only one structural element. Okay, so that is table or bullet list, and if only if that helps to clarify. It shouldn't happen that there are multiple tables or multiple bulleted lists. So just use one structural element. So one specific example case study, if available, starts with bold insight, no preamble prior to creating the section. Okay. What it means is this is a section about explanation on the concepts of so and so thing. So this kind of a statement is what we call as a preamble. It should directly start with the content of the section rather than uh, below is the section content that you have asked for in 250 words. So these kind of headers you normally get when you do the same task in ChatGPT, if you remember, right? So those kind of preamble things can be avoided. And then if there are special characters, you need to escape it properly and so on. Okay, so let's execute this. Okay, so now the node function, which is going to actually execute within the node. So I'm going to provide that from prompt template here. Okay. Section writer prompt. This is my section writer prompt. And we are going to populate the title, topic, and the context from the state. So I'm just pulling the section and the source from the states, you can see. And writing this section gets printed. And all of these are populated there. Finally, the LLM invoke will generate the section content based on the schema. Okay, fine. So the system and the user prompts are already there. You can see. And here we have the section state, which is the input. Okay. And that is where, that is what will define how this LLM's output would be structured. Okay. So I'm pulling the content part from the section content and just printing it. Okay. Any questions still here? All good? Okay, so now this agent, which is more specifically a sub-agent, will be called several times in parallel, and one for each section that we have already discussed. So here we are going to build the search web. It's not defined. Acha. Yeah. So we are building the nodes and just connecting them. So generate queries will go to the search web, and that will go to the section writers. Okay. So this is this part essentially. Okay. So that is one agent or sub-agent. Now that will be called by the other planner agent. Now create dynamic node function. So how was that done? If you see, the nodes are being added, generate queries, search web, and the section writer. And then we are just adding the edges. Edges are nothing but the simple connections that you have. Now, how do you parallelize? We had seen that the parallelization is achieved by using the send function. Okay. So here we are going to send the section builder with web search. This is my section builder with web search. Okay. That is the name of the sub-agent, which will be called multiple times in parallel as there are number of sections. Now this is for the formatting. So within that, what happens? So format sections again. This is just initial formatting, so equal to, and then the section title will be there, section description, followed by the research, which was generated by doing the Tavily search. Okay. So if this content is empty, then it will simply fill it with not yet written. Otherwise, it will have the actual content. So once this is triggered, it will start doing the search. And based on that search, it will write the content. Okay. So until the content is not written, it will be in this kind of a state. So this format completed section. So this guy will keep a track of which all sections are completed and then format them. Okay. So formatting completed. So here, if you see, where are we going to use that format? If you go to the main diagram, this is the format sections block. Okay. Where we are going to use that agent. So agent for formatting also. There is the agent for formatting. So now the final section writer, which will generate the introduction and the conclusion part. So again, this is the main prompt, title of the entire section, section topic, context is there, and this is again more or less similar. Okay. 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 And now we also want to parallelly execute that two times, one for the introduction and one for the conclusion. So that is where again you will create a function for write final sections, and this function will be called by the send function. The send function will parallelize this function ultimately. So two instances of this function would be used. Okay, and you can see that send function is calling that write final sections function. Okay, so one each time, one for the introduction and one for the conclusion part. Okay, and now the compilation part. Let's see how it goes. So again, report state, we are importing all the states from there. And by this time, we would have the knowledge of the title of the article, sections and everything, and also the completed section. So this will keep a track that which all sections have completed. Based on that, it will, see the progress of generating the final report. Okay. So here what we are doing is simply joining these sections, okay, which has been written by our individual agents, introduction, section, and conclusion. Okay. So this compilation is nothing but just joining the sections as of now. Okay, back to back. And some placeholders we are creating. Okay, especially for dollar signs and so on. So if there is any dollar sign still remaining in the formatted section, which is not properly formatted, you can uh, do this regular expression based search and match. So this is the same diagram once again, finally, and let's build a complete agent now. I'm just displaying this agent. Oh, image is not defined. Why so? Okay. So we have got this complete agent, start, generate report plan. And this is again where it is going to go parallel. Okay, generate query, search web, write section. Once the sections have been written, formatting happens. And again, if you see, there is a dotted line here, which means this final write section, okay, will be again run in parallel or something is running parallelly over there. And this part, again, you can see is going to run in parallel because of this dotted. So this dotted thing ensures that this part is going to run in parallel multiple times as there are a number of sections. And similarly, there is one more dotted thing here. If you see this, so that ensures that the final section is also going to run in parallel multiple times, one for introduction and one for conclusion. Okay, now we are ready to test our agent. So detailed report on how to build AI agentic systems, design patterns, and concurrent frameworks. Let's see what we get. So generating the report plan. So this entire execution might take few minutes because now in the report generation plan, again, it is doing web search, and then yeah, plan is completed, queries are generated, and based on all those queries, the sections are created. So how many sections we have created? You can see understanding agentic AI, then design patterns, then current frameworks, real world applications, challenges and considerations, and current frameworks. So these are the no, these are the 5 sections. And then the search results for each of the 5 sections parallelly done. So if you notice, this 5 came almost instantly. Okay. And then this queries for each of these generated, searching web, you can see. So that is done. And now the section writing is happening. Okay. All the 5 sections completed. And now what is happening is the introduction and conclusions are written in parallel, are being written in parallel. So they will appear at once, both of them together. Yeah, so that is what I mentioned. So introduction and conclusion is also done. And now you can see introduction is completed because introduction and conclusion are going to, do in parallel. So conclusion also completed, fine. And that goes to the final compilation, which is pretty much uh, concatenation of the report. Okay. And there comes the final report. So introduction, agentic AI systems, understanding agentic AI, autonomy, potential with some sources. Okay. What do they mean for procurement? What is agentic AI Salesforce? So some of these you can see. Again, design patterns, reflection pattern, tool use, planning, multi-agent collaboration. So this is what we are doing currently. Okay. Tool use we have seen, reflection also we have seen, planning also we had seen. Okay. Current frameworks for building agentic AI, LangChain based LangGraph, OpenAI Swarm platform is there. And very recently, OpenAI also has released one more. Okay. SDK, top 5 agentic frameworks to watch, and so on. And real world applications, you can see. Interesting to see here, healthcare, Adelaide's core, an AI-driven tool trailed at some hospital in, no, trialed, sorry, in some hospital, exemplifies this impact. And then it analyzes patient data to predict discharge readiness, okay, reducing 7-day readmission rates, saving $735,000 in 28 days. Great. Retail. Walmart is already using AI system, processing 500 million price points weekly, adjusting 50,000 items, increasing profit margin by 12%. So literally it is using agents to decide on the prices of the items, it seems, right? Based on the inventory and the consumption and the consumption patterns, maybe also based on the weekdays, weekends, availability, consumptions on specific days, holidays. So all of these decide. So if there is more demand, especially during holidays or during the weekends, the price would be slightly higher. During the weekdays, let's say, where there is less demand, the price would be lower. Okay. So that way they are increasing the profit margins. Zara's AI predicts demand with 85% accuracy, streamlining inventory management across 2000 stores. Great. Finance strategies based on market data, enhancing decision making speed and accuracy. In banking, AI driven treasury automation optimizes cash management, integrating real time data for continuous operations, and so on. Okay, perfect. So we have got some of these, you can see. And challenges, you can read. Bias could be there, transparency, data privacy, standard issues. And then finally, conclusion about this. Now, the overall, if you see, this looks pretty good given the constraints that we had given for 300 or 250 to 300 words. If that constraint was not there, let's say, okay, maybe you can increase that constraint to 1000, and the level of detailing that you might get would be much, much higher. Okay.
So that brings us to the end of today's session. I hope this breakdown of multi-agent report automation gave you clarity on how you can use AI to save hours of manual effort and build smarter workflows. And if you found this helpful, make sure to hit the like button, subscribe, and turn on notifications so you never miss our upcoming AI and cloud videos. And also, if you're serious about landing a high-paying job in AI, ML, or Agentic AI, don't forget to register for a completely free masterclass that I mentioned. You can check out the link in the description or pinned comments to register. So thanks for watching, and I'll see you in the next video.